Okay, so today we're going to talk about Python functions. This is a very fundamental stuff of coding, of course. And the C++ version is in Computer Science 110 and 165 DVC. Okay, so the study goal is the first thing is a function definition. Um, oh, I say like it's a basic structure of function, and then can we keep track of the values when function is running or in the data in and out from the function, and how does the diagram look like? And we're going to introduce environmental diagram. So for this lecture, I really want to suggest you guys to prepare a pen and two pieces of paper because we're going to draw some diagrams, like actually on paper. And if you have an iPad, that's fine. And open up the Python tutor.com because we also use that for some demonstration. But I will display the Python tutor the stuff, the logic at this tool. Okay, so we cover next week is the pure non-pure function and lambda function. All right. So the first thing is function definition. So what does a function do? Like in other way, what is a function? So no matter what, you go from mathematically, verbally, or logically, it is like a function typically receives an input or some inputs, and then you return the result according to the algorithm you created in the function. And this is typically what it's do. And so we have input, output, and algorithm inside the function. I noticed that I said and or, like because actually you may see some functions they don't have input or they don't have output or they don't even have a logarithm. Um, So they are optional, but typically they basically receive something and output something based on some algorithms. All right. So this is the sample function we'll use today. So this is the function. Let's take a look. And the first line from map import square root. So this means that I have to import the algorithm square root from the map library of Python, but it's not a it does not really matter in our lecture. Like just know about it. So we have to now we're going to analyze the function line by line. So the first line is input. So the input is that you have defined keyword which is called def, and then you have the function name root sum. And then you have the parameter and arguments. I will discuss about two differences later, and a column at the back. This is the input entrance of the function. Like you basically just have input here, and then you go along this function. And the next line is called assert. Assert means that you to filter out incorrect inputs. Like for example, I have s greater or equal than 0, y greater or equal than 0, and c equal or greater than 0. So these are the conditions of the function inputs we are to require. And like as we all know, like in the square root, the stuff inside s must be greater or equal to 0. So if you do put a negative number inside, it will cause an error. So that's why we have to filter that. And okay. So the format of assert is like assert the keyword and then the condition you want the data to satisfy, and then semicolon, and then the comment. The comment means that if here, if we go wrong at this place, it will display the information here saying that, oh, you should be only positive or 0. And then if inputs are all good and nothing happens, and the data will be passed into the function to run them. And else raise an error called assertion error, right? So okay, the next thing is the main function body, like which you usually do some algorithms. And the last one is called return statement. Like return statement basically returns the output of your function. Output. If you do not have the return statement, it will output nothing. Like if you want to calculate something and you only have the input, and you do not have, if you don't have a return statement, it will return nothing, and then the result of the function calculation will be none. Yeah. Okay. So, any questions about this? Like basically the four stuff to create a function. And this is called function definition, which means that we have to define the function, create a function so that it can be used to solve problems. Okay. Oh, any questions about it? Okay. All right. So the next thing, what's the difference between a parameter and an argument? So the parameter is the tool that passes the input variables or values into the function. Like it's kind of like a gateway of a building. And the arguments are the values being passed into the function. Oh my God. Being passed into function. So let's see the example of this. So the whole thing, the thing including the parenthesis is the parameter, and then the variables inside. The variables inside is called arguments. So parameter is like a gateway of a building, and the arguments are like people coming in and out. Oh, only coming in like it because it's the entrance is coming into the buildings. Okay, so suppose we have a function y equals x squared plus 1, and x is the argument of the function. Okay, so which means that if a parameter can be empty, if you do not have values passed into it. So suppose you say like def root sum and then only a parenthesis which is empty. So that means that you do not have to like and there can like they also the function does not allow you to pass into the value into the function. Okay. Oh, any questions about this? Parameter arguments. Okay. Right. So here's a small question. Which of the following are necessary to build a function? Like, we can do a very quick quiz kind of about it. Yeah. Um, let's have 2 minutes to find out the answers, and you guys can type your answer into the chat box. Yeah, let's have 2 minutes. So, uh, which of the following are necessary to build a function? We have defined keywords, function names, parameter, arguments, assertion statement, main function body, and return statement. Like the answer is there are more than one. Like the hint is that. Okay. Do you guys have any ideas about it? Hey, hey, are you guys awake? Hmm, thinking. All right. I guess I write down the format. Kind of define and the name, and then the parameters and arguments, and then assert the body, and then return. The answer is more than one. There are more than one answer. Not exactly. All right. Okay. So the answer is like the answer is def keywords, function names, and parameter. As I said, like the depth and the name and the parameter, they are three basic stuff you want to create a function. And because you don't have to pass in, you don't actually have to pass in arguments, and also you don't uh, have the assert statement, because if you don't have a assert statement, they can actually like there will be no value passing, but it's fine. And the main function body, like it can be empty and return statement. You don't have that because if you want to have return statement, you must be wanting to return something. But since you are not going to return something, maybe, so you don't actually have a return statement. However, if you don't have the defined keyword, function name, parameter, that means that's not a function. And yeah, but like if we have a function kind of like only have this three uh, this three stuff, which means that the function does nothing. Yeah, but it is a function though. All right, but we have arguments, return statement, which is typically what function do. Yeah, okay. So next thing is function calls. All right. So function call is like what does a like the first thing is what does a call do? Like for example, a client calls a customer service to say like blah blah about my product. Like I bought something. I bought an iPad from Amazon, and it goes wrong. And I say I talk to the customer service, and they will give me solutions about how I'm going to refund or something. Um, or for another example, if I left my key at home, and when I go go back home, and then I found that I left my key at home, so I have to call my roommate, saying that like, oh, I left my key at home, so you're gonna open the door for me, and then the roommate came and opened the door for you. So which means that if you call somebody and ask them to do something, like probably they can help you to deal with your problem. So this is what a function do. So just like how phone calls do, like call customer service and they help you with your purchases. Call 911, they help you with emergencies. So you call a function, so you can use the function, which means that you can get the help from the function you created. Like the helps can be calculating, making decisions, etc. So function call is like how you use your function. Function definition is um, how uh, how you create a function. And then after creating that, you want to use that. So call a function so you can use it. And when you call a function, this is called a function call. So here's an example. So this is the function definition of the root sum, like which we had previously. And then example of function call. So on the terminal front end, when you say a equals to root sum, so this is the function name, and then the inputs with the parameter, and you get the numbers 3, 2, 3, 4, and then next time you type a, it binds the value, you return the value. So according to the assign rule, like there's an equal sign here, and then you evaluate the stuff from the right, and you goes into the function, and then do calculation, and after that, oh, I got the result 5, and then you bind the value 5 to a. So this is the assign rule. So you call a function, and then like if you have return statement in the function, they will return something, return this solution to you. Okay, so let's do an example. Mm, so this is the function. Okay, and then at the terminal. So let's see, then all right. So we want to do the root sum, and then you put in 2, 3, 4, and then you type a. So it returns 5. Another thing, if you like want to return like one 2, 4, return another solution, like which is 4. So this is the function call. You call a function and put in your data here, and the next time you call this variable, it will have the solution, which is returned by the function call. Okay, right. Okay, so I have a quick question. What does c equals 0 do here? So the z equals to 0 means that the default value of c is 0, which means that uh, I I don't have to actually input the data as a c value. I don't have to input the third value. If I input the third value, the c will become the third value, like which is 4. If I only have 2, 3, so if I have only 2 and 3, the zero inside will be 0. This is the default, and yeah, so this is what c equals 0 do. So, but instead, if you don't input the data at x or y, it will return an error because it's saying that like you have to pass how many values into the function, but actually you didn't reach the number, or maybe you exceed the number. If you input 1, 2, 3, 4, like obviously there's no enough space, so it will also return an error. Okay, so maybe you guys noticed that like how the root sum do. The root sum is actually like returns the calculating the distance between a space. So maybe you have the Pythagorean theorem, or maybe a distance at the kind of 3D space. So this is what's do. Like if you only calculate the distance at the 2D world, you don't have to input the c value, so it becomes 0, like which makes sense. Okay, so function calls is like the kind is the variable a, and then the function is the root sum, and I have the definition here. So the client calls the customer service. So input the data, provide information, x equals 2, y equals 3, and z equals 4. And then the function returns the result. The solution is 5. And then you must have a return statement to return the result. The return statement is like the mouth of the customer service staff. So if he or she does not have a mouth, or yeah, like you cannot like answer the client. So which is like kind of makes sense. Okay, any questions about it? Mm, about the function call. Mm, okay, all right. Let's move on. Okay, so oh no, okay. So let's do the introduction to environments. So what is an environment? Environment is kind of like a range in in the Python interpreter file. So like which means that it's kind of like suppose you're in America, and then the environment is like the range of the territory. In Python, there can be different environments where variables with the same names have different values, and the function with the same names may have different behaviors. So it's kind of like if you are in different range, even though you have the same thing, like if even though you have the same name, it doesn't mean they are gonna be the same. So for example, we have a city called Dublin in California, and we also have a city called Dublin in Ireland. But you're not gonna say the two cities are the same, like only based on their same name. Um, so this is basically the same idea of it. So when you're in different environment, and even though you have two names which are the same, it doesn't mean they are the same thing. So which you have to be very careful about it. And this is very similar to the idea of scope in C++. So variables and functions in different scopes may have different I may have different behaviors, may have different values. Okay, so we also call an environment as a frame. In Python, we call it a frame. And a function called opens a new frame. Yeah, this is very important. Like based on this, we're going to have a lot of things to talk about it. And based on that, we have variables, like even though they have the same name, when they are based on different environments, they may have different behaviors and values. So which means that we have to keep track of the data, like where they are and what they called and what the values they're bound to. So this is the example of an environmental diagram. We use that to keep track of the data here. So here's the sample code. So x equals 1, then x equals 1, y equals 2, and z equals 3. And function. The function, it read that it reads the function code, the line as the function. So it say the object is a function one. And we can do the example of it, the demonstration of it. Okay. Uh, so it's like x equal to 1. Like this is the next line to execute. So it reads this line. And then after executing this line, it move on to the code below, like which follows the order, like from top to bottom. When you run the code, like no matter in C++ or Python, and you reach that like, okay, x is bound to 1, and y is bound to 2, z is bound to 3. And I read the function definition. So this is func1. So say, okay, the name is func1 and the object is a function. Okay, so this is a very simple environmental diagram. Okay, so in Python, the very outside frame is called global frame, which is the ancestor of all frames. So global frame is like the idea of global, the globe. Like for example, you live on Earth, and no matter which country you are from, you are in, like so let's say you're in China or you're in America, you're in Canada. That means that you are still on Earth. You are still in the globe. So global frame means that the range of the frame is actually everywhere in the function file, in the Python file. So let's say the global frame, like we have 11 lines of codes here. So the global frame is actually all of them. Yeah, all of them are in the global frame. And the global frame is the basic one, the very bottom one of the frame. And you may create new frames, but based on this global frame, and then you kind of like doing a stack and you stack it. But the basic one, the global frame. And we will talk about why global frame is the ancestor of all frames. Like we talk about that later. So let's do the environmental diagram of this line, of this file. Like we have some initial values and we have the function. Okay, so you're gonna read that. Like this is the red line is about to execute and the green arrow is just executing. So we do like we read about x equals 1. Oh, you don't have to think about, you don't have to notice it. X equals 1, y equals 4, z equals 9. And I keep all the values of x, y, z. And then I'll do another one. Oh, okay. I read the line of a function. So this is the function definition. Function definitions do not open a new frame. Like remember, like this only shows that I create and I define the function at this frame. It doesn't mean I call them. Like it means that I just created an object. It doesn't mean I use the object. When you use the object, like let's say when you use the function, it opens a new frame. But for here, right now, we do not open a new frame. So we read about this stuff. This object is called root sum, and the object type is function. Okay, so the parent is global. The parent frame is that when you create a function, like based on which frame, in which frame you created, like because the function is defined let's say is creative at the global frame. So which means that the parent of this function is the global frame. Okay. And then so we read about the function, and then the next step we read about, like, we skip up them because they are all the function definition. And we do not execute them because we are not going to use the function. We only know, oh, here's a function, and that's it. And then we skip to result. And then we read about the result line. And then result line say, oh, here's a function call. So we are going to open a new frame. Okay, all right. So here are some other notes. A function call creates a new frame, and the frame where the function is defined is called its parent frame. Like some functions, like I guess most functions are defined in parent, like in global frame, which means that their parent frames are the same. They are all global frames, all global frames. But like there may be other functions that are defined in some new frames created by other functions. We will discuss that 2 weeks from now. And so we know the parent frame is that a function where the function is defined. It's actually called dynamic type. Like we have lexical and dynamic, and where the function is defined is called its parent frame. This is called that dynamic type. Like this language is called a dynamic type of language. Okay, isn't the program start from 6 to 11 work individually? Let's see. 6 to 11. Yeah, because like as I just said, like we only read about that. Here we created a function. We define the function, and then that's it. Like if you really want to run the code inside the function, you have to call the function. But for right now, at the line 6, 7, we do not run the function. We do not call a function. So which means that we are not going to run the function. So we just skip to the stuff after the function. So right here, we said that here we define the function, and that's it. So we go past it. And then next time, if you want to run the code inside the function, you have to call that. You call that, and then you use the function, and the program will run the function. So which means that we will go into the steps here. So we will do that later. And we are talking about some other additional information, some important notes. Yeah. Okay. So the frame where the function is running is called current frame. Yeah. And or F1, F2, like we may create some new frames and we stack it, and then we'll have F frame 1, frame 2, etc. And the Python, the program is executing codes. The function definition will be known. Like the program, we know that, oh, here we have the Python, the function definition, but we are not going to run that because the function runs only when it is called. And when it runs, it will create a new frame, and it will run in within the new frame, the function call creates. So when the function is running, if you cannot find the variables defined as frame, it will look it up to the parent frame or parents frames, parent frames. Like let's have a small example. Let's say x equals to 1, and you define the function here. And then you may want to return x. But the variable argument passing is called y. So I cannot find x in this function. But we know that it is defined in global frame. So we only have to look into the parents frame, and then to see if we have a variable called x, because we only have the variable called y in this function. So we have to look it up in the function. So we have to keep track of the global frame, like which is the parent frame of the function. And then I'll say, oh, I found x equals 1. So which means that I return 1. Yeah. If I call this C, it will have an error because I can't find C in my function, and I also can't find C in my global frame, which is the parent frame of the function. So you see, we cannot find the variable C, so it will raise an error called name error, which means that we don't have a variable named C here. Okay. Mm, So it will look it up to the frame, the ancestors, until it hit the global frame. If we cannot find that in the global frame, it means that we cannot find a variable, name the thing we want to look it up, and which means that it will have an error. So that's why the global frame is called the ancestor of all frames, because when you find want to look it out the variable in a new frame, you have to look back to the parent frame until we have the global frame. And the global frame is the very bottom frame, like which means that the global frame does not have parent frame. So let's think about this relationship. So it's like global frame is the father and grandfather of all frames. Yeah. So this is why I say if it reaches the global frame, but still could not find the variable, it raises an error called name error. Okay. So so now we execute this line and we find that, oh, this is a function call. So we have to um, return to this function, and then we put the variables inside the function, and then we open a new frame. So I call that frame one. So the function calls to open a new frame. So the frame is it only executes the codes inside the function because the frame is created by the function call, and the codes um okay so we only execute the lines in this function, and upload we upload the inputs to the function. So we bind 1 to x, we bind 4 to y, and then we can keep set the value xy is 1 4. Like even though they are the same, but they have the same values, it doesn't mean they are the same thing. um if I do yx here, so it means that in F1, so X will be, we have to evaluate Y in the global frame. So Y is 4, so X will be 4. And Y, we evaluate S at the global frame. So X is 1, so it is 1. So, uh, so what I say is like the X value, the X variable and the Y variable here in the frame 1, um, they are not the same thing as even though they have the same name. Okay. And it opens a new frame, and the frame is different from the global frame. And then we have to execute the lines one by one here until we hit the return statement, and then you return the result to the root sum, and then it will bind the value to the result. So so and then we execute the lines. We execute the lines here, and then we find out, okay, we have a new variable called solution. So we have solution, we do calculation and find the solution is 6.0. And then we hit the return value. So we have the return value here. I notice that if you do not have the return statement here, you do not have the return value. So the return value is returned to the variable where the function is called. Okay, so return, and then the result will be 6.0. So return statement returns the value to the variable where the function is called. So it returns 6. If you do not have the return value here, the result will be none. Yeah. All right. Any questions about it? So the basic idea is that like the very first thing you run the function is that you run the codes in the global frame, like um, runs all along that, and you skip the function definition because you know that it is the function object, and that's it. You go past. If you want to run the Python codes inside the function, you have to call the function, and then you input your values in it. And when you call a function, you create a new frame. So when you create a new frame, it opens access to uh, the codes in the function. So it will run this line of code until it hit the return statement or maybe to the end of the function, and then it will return the value. It will return the value to the variable which has an assign assign operator with the function call. Okay. So yeah, any questions about it? Let's see. Okay. Yeah, I guess we can have a little small practice about to draw a Env diagram. Like hopefully, oh, I didn't notice you guys I didn't notify you guys that I guess you should like draw the environmental diagram on the paper when I do the presentation. Um, oh, I forgot to have a demonstration about it. Like, let's do it. Let's see. Oh my God. Wait a minute. Okay, so we have a small demonstration about the codes we have because I may talk about it like kind of abstract. All right. So then we run in the Python tutor and we are doing the environmental diagram. So um, we have to execute next. See, the red line is to execute this line. But we don't have to know about it. Like we know from the line 3. So we keep track of the value x equals to 1, y equals to 4, and z equals to 9. Okay. So we have the defined root sum. Here is a function here, and we have the name and the object type is a function. The name is called root sum, and then we skip the function, and then we go to the line 11, which is the function call. We have the result. So it immediately opens a new frame called F1, and we keep track the function. The frame 1 is actually running the codes in the function called root sum, and then we keep track of the parent frame, which is the global frame, and then we upload all the input values to the arguments. Yeah, and then we have solution. We calculate that the solution, we got solution is 6.0, and then we do the return value. We do the return value of 6, and then we will return that to the global frame and bind that to the variable called result. So this is the whole environmental diagram of this code. Okay, so we can do a little bit tricky thing here, like let's say we may input y, x, z. Okay, and then we keep check the data, and we find that the F1 root sum, like y is x bound to 4, because we do evaluate y first and bind the value of y, the global frame, the y in the global frame. We found the y in the global frame, and then note that the value is 4, and then we bind the value 4 to the x variable in the frame 1. So although they have the same name, they are different objects. Okay, so y is 1 because we evaluate x on the global frame, and then we got 1 because x on the global frame is 1, and then we got c equals to 9. So c is also the same c here, so it's 9, and no issue about it. Okay, so yeah, any questions about it? Any questions about this file? And if it's okay, we can do a practice. We use about 10 to 15 minutes to do another practice, which is a little bit harder. Okay. So yeah, any questions about it? Okay. Remember the root sum on the global frame, we don't go into the function. Like we know about that this is a function definition. So we just skip that because when you open the frame and run the code in the function, you have to call it first. Yeah. Definition only means that you create a function here. Like it doesn't mean you use it. Yeah. Okay. Um, let's do the practice of it. We have 15 minutes to do this. Like you draw the environmental diagram of this, and then uh I will draw the environmental diagram to you. So and also we can run it on the Python tutor.com to see how's that actually going. And the hint of this environmental diagram is that we have three new frames apart from the global frame. Yeah, because we have three function calls. Okay, so let's have 15 minutes to do this. Yeah, you can draw the environmental diagram of this, but you don't have to show me. Like it's only a practice, but I will show you my solution of this problem of the environmental diagram. Okay, so yeah, so you can draw the environmental diagram now. Mm, yeah, I guess I can have an example of this, like for you to do some kind of references. Mm, okay, so this is the environmental diagram of this guy. And then here's the, oh my God. Uh, here's the question. Yeah. Oh, okay. 64 is far less than the result. Yeah. Oh, sorry. The result is far less than 64. Uh, is actually less than 20. If you are really not sure about your answer, you type all the codes into type Python interpreter and run that. And remember to add a line. Um, remember to say print result, and then you see the result. Yeah. Okay. Yeah. Env diagram is very important to um it's very important to keep track of the data when you trying to learn coding, and then you're not sure why you got wrong results, or when you're not sure when you got wrong some kind of like errors, and then you say, oh, I have to run the lines, run the codes line by line, and then to see what's going on among them. Yeah. And also when you transfer to Berkeley and you take CS61A course, uh, this is very likely that they will put such questions into the exams. Yeah. So it's kind of not as hard as you think as long as you practice a lot. Like my dad told me he practiced about 10 times in order to get it through. So you also have the C++ Python tutor though, like you have to search it on Google, and then you have C++. If you learn C++, you can keep track of the values. Mhm. Yeah, you have to be very careful because when I first did the problem I created, I also got wrong. Yeah. Mm, okay. You guys finish it? Like we can get started, I guess. Yeah. I think you guys can hear me. Yeah. Okay. Okay. Also, like after finishing the lecture, I will give away the record and the PowerPoints, and also I will do a mind map. So yeah, you guys can review it anytime you want. If you finish, you can just type one, and yeah. Okay, all right. What about Qing Rui? Yeah, yeah. I saw Edward. He's finished.
I have no question for now.
Oh, you have a questions about.
I have no question for now.
Okay, you finish. You finish right. Drawing the diagram.
Not yet. I'm still
Are you still working on it? Oh,
digest the knowledge.
oh, it's okay. 2 minutes left. Yeah, can think about it. Uh-huh. The answer is actually 19. Yeah, let's see if you got it right. There are many modulus and flow divide here, so maybe people get confused. All right. Okay. Let's do the problem together. Yeah. I will show. Oh, can you run in steps? Yeah, sure. Yeah, why not? Sure. Okay. So let's see. Like we go into the global frame. The first step you say like you write this is global frame, and you say x equals 50, and then you have line 2 y equals to 41, and then c equals to 5, and then you have line 4. So define function 1. So you say here is only the definition. So you evaluate the stuff. The object is a function, and that's it. So you say object function, and the parent is global. And then you also have the function 2. Because you skip that, you don't write the codes in it because you didn't call the function. So it just do the it just you just know that, oh, I have a definition here and that's it. So you skip to function 2, and it basically do the same thing. So you say like they are both the functions and their parent frames are global frame. Okay, and then you skip function 2, and then you have the result. Okay, I have a variable for result, and then I have to do the calculation here. So we created a new frame from now. So okay, any questions about this step? So we're running on the global frame, and now let's skip it into frame 1. So we have the first function call. Okay, so and then we do frame 1 and function. The name like frame 1 is running on function 1. So the parent frame of function 1 is global. And then we have to know, okay, I have arguments here, the input x and y. What is x? X is 1. And what is y? Y is the x on the global frame. Where is the x on the global frame? Okay, it's 50. 50. So uh so we have this is 50. Okay. So and then uh, we do that. Okay, here's a new variable called solution. So how is solution calculated? Like I said, 1 mod 2, and then plus 50, 4 divide 3. So 1 mod 2 is like we have to find the remainder. So here's 0, we got 0, so the remainder is 1. So here's 1, and then plus 50, 4 divided 3. So we do 1, and then 3, so it's 20, 20 divided by 3, so get 16. Okay, 16. So I think that's it. So here's a decimal. So we do 16. 1 plus 16 is 17. Okay. So we got the first result, which is 17. Yeah. And then we return the solution. But notice that the return value I will basically write as RV, and then return value is solution 4 divided by 2. So 17 4 divided by 2 is like the closest one is 16, like so it's 8. Okay, so we have here result here is A plus. Now we do the second function call. So we have F2 is function 2, and the global frame, the parent frame is the global frame. And then we do also XY, like because we have XY here. Yeah. So and then we'll see. Okay. We return C. Oh, sorry. We have XY, and then we evaluate. So X is bound to Y on the global frame, and what is Y on the global frame? So it's 41. It's 41. So, and then X is 41, and Y is 2. So, okay. So Y is 2. And then we have also we see here, I guess it's not actually very necessary because we do return statement immediately. And then, okay, we return value. So where to find C in our frame? So we don't have a C value in the frame 2, so we have to look it up in the global frame. So the global frame of C, on the C on the global frame is 5. So here we say 5, and then plus func1 yx. So which is like actually here we're doing another function call. So which means that we open a new frame F3. So this is func1 and parent equals to global. And for func1, we have the value here. So we have xy, and xy is the input, and we do the evaluation in frame 2 because the y-axis in frame 2. So we have to see, okay, we evaluate xy, and then x is the y on frame 2. So y is 2, and okay, x is 2. X on frame 3 is 2, and okay, and then is do y on frame 3 is x on frame 2. So x on frame 2 is 41. Okay, so 41. And then you do the function 1 again. So which is solution. Solution is like 2 mod 2 plus 41 4 divided by 3. Okay, I think that's the one. Okay, yeah. So 2 mod 2 is 0. Yeah, because 2 is an even number, and then plus 41 4 divided 3. So 41. Yeah, so we got 13. So 0 plus 13 is 13, and then we return value. Like notice that we actually do 13 4 divided by 2. Yeah. So 13 4 divided by 2. It's 12 4 divided, so it's 6. So you return 6 to here. Yeah, because you return C plus fun1. So the function call is here, so you return 6 to here. So it means that this is 11. And then you return it again to here. Yeah, because you return the function, you return the value of frame2, and then it goes to here. It goes to the return here, so that you do A plus 11. So which means it's 19. Yeah, so the result is 19. We can do the demonstration of it also on pythontutor.com. I also have that. Okay. Let's see. Yeah, actually this one. Okay. So on the global family, I have x equals 50 and y is 41, z is 5, and then you find out two functions here, and then you go to result. Result is you create the first frame, so it's fun1, parent equals to global, and x is 50, x is 1, and y is 50. So okay, solution is 17, but with 40y, so it's 8. So, and then you return to this, and then you have another function call, which calls fun2. So you have fun2, parent equals to global, and x is 41. Yeah, because you evaluate y on the global frame, so it's 41, and then y is 2. So you also return. So you found out c is 5, but you have another function call. So it's frame 3. So the function call is fun1. So you have x equals to 2. So x evaluates y on the frame 2. So frame 2, the y on frame 2 is 2. And then you have x. X on frame 2 is 41. So you have x equals 2, y equals to 41. And then you do it over again, and then you have solution 13, and then 4 divided by 2, 6, and then you return to here. So you return 6 to here, and then you add 5, so it becomes 11, and then you return 11 and 8 all together to result and add it up together, so you get 19. Yeah, so that's it. All right, do you have questions about it? Yeah. You can have a lot of practice problems here. Let's see. Uh, links, and then pass exam. So you have a lot of topics on it. Environmental diagram. Yeah. Oh my God. I guess this is my meetings. Yeah. So yeah, you can do a lot of this if you like. Yeah, here's a lot, and you can do lots of practice problems. Yeah, it's this one. Yeah. All right. Any final questions about today's lecture? Yeah, it's over an hour. All right. I think that's it. Yeah, you're welcome. Yeah, you can ask me questions anytime you want, like through WeChat and Instagram, maybe. Yeah. Okay. Um, all right. I think that's it. Yeah. Thank you guys for coming, and thank you guys for supporting me. Really appreciate that. And hopefully you can actually learn something from it. Like I made a lot of efforts, and yeah, because it's kind of it's very useful and helpful when you actually learn Python, even though you are not, maybe you might not be going to UC Berkeley, but it is still very useful. Yeah. Okay. Uh, all right. Thank you guys.
Thank you. Bye bye.
Bye bye.